All right, welcome back for part 2, ladies and gentlemen. So we're going to start off probably the most important theorem that you really want to take away from this particular lesson here. So the key is that we have ABC being a triangle here. So we have just any triangle ABC, and we have two midpoints here. The midpoints are two sides of the triangle. So it looks like this here. So you have triangle ABC here. You have D as the midpoint of AB, and you have E as the midpoint of AC here, okay? So this segment DE here, that's a very important segment, and we give this a name here. So we refer to this DE here, this is known as a mid-segment, okay? Because it's a segment that joins the midpoints of two sides of a triangle here. So this particular segment has several properties here. We're going to try to learn what these properties are based on what we have. So right now we really don't have a lot of things that we can do with this here, but there are definitely things that we can sort of figure out from there. So the proof that I'm about to show you is only one such possible proof here. There are other ways to prove this particular theorem here. But you'll note that there's going to be a lot of similarities to what we did here before. Okay? So in something like this here, let me go ahead and do the following. I'm going to go ahead and do this. I'm going to extend DE its own length here. So I'm going to create a new point like this. I'll call this point here F. So basically what happened here is I created EF extension of DE. So DE is congruent to EF here. And then we're going to connect F to C. Okay? So essentially what's going on here is we have this. Okay. Well now, the nice part about this is that it actually throws a lot of things into the mix here. We have a lot of pieces of information. So in particular here, if you notice that we have here from this, we have AE and EC. Those are two congruent pieces that we have here. Some of you may note, wait a minute, I've got enough information for some triangles here. AE and EC are congruent here. DE and EF are congruent by my construction here. And I think you can see in between here these two angles, because these are intersecting lines, we've got vertical angles here. So it looks like here something like this works out very, very nicely here. So we can say that triangle ADE is congruent to triangle FCE by side angle side, right? So that's going to be really nice. So notice how in this sort of setup here we have side angle side here showing that these two triangles here, triangle 1 and triangle 2 here, these two triangles are indeed congruent to one another. Okay, well that's great because there's a bunch of things that we can do. Notice we never touched this portion here, so I can kind of do something with that now. I know that AD here and DB are congruent from the information that was given to us here. So AD being congruent to DB, well let's see. AD here matches with FC, so AD and FC match, so they're congruent to one another here. And now that means that DB and FC are congruent. That's great. Now, another thing to note here is that, in addition to congruent sides, there are also congruent angles here. In particular, you can pick any of the pair. In particular, I can pick angle A up here and angle FCE down here. These two angles in purple are congruent here, right? Now, wait a minute. Hold on. These two are purple angles. They're both congruent here. And if you take a look at the picture, we now have AD and FC here. These two bits, these two line segments here, these two purple angles are ultimate interior angles. So that means that AB is parallel to FC. So I can conclude this here. Right? AB is parallel to FC, which means that since DB is a portion of AB, it's also parallel to FC. Wait a minute, hold on. Take a look at what's going on here, ladies and gentlemen. Now we take a look at this quadrilateral DBCF. So here, we seem to have the fact that DBCF, well, what do you know about it? Well, look at what we have. We've just shown that DB is congruent to CF here. From that, we've also shown it's parallel. So we can say it's a parallelogram. Since we have that DB is congruent to CF, and DB is parallel to CF, right? So it's not too hard to show this here, and that's really important. The reason it's important was, well, let's take a look at this here. Now that we know that DBCF here, this entire thing here, DBCF is a parallelogram, well, that tells us a lot about this here. So DF and DC here must be parallel to one another. So I can go ahead and mention that here. So this here has to be parallel to this. And since DE is a portion of that, we know that's the case here. So this allows us to conclude here some rather important things. We now know that DE is parallel to BC here. So that's important, right? That's going to be really a big thing about this mid-segment here. Now, of course, we can also do another thing here. Note that in this case, we know DE is congruent to EF. That's going to be important here, right? So we know that the opposite sides of a parallelogram, not only are they parallel, they're also congruent as well. So that's going to be important here. So another thing we can also conclude here is that DF equals BC here, right? They're congruent to one another. However, because they're congruent to one another, we know that in this case DF is DE plus EF here. That's going to be equal to BC, right? But since DE and EF were the same from up here, we can set them equal to each other. We can set these equal to each other. So I know that 2 times DE equals BC here. And as a result, I can divide both sides by 2. And we end up with DE equals 1/2 of BC here. So, from the beginning here, you might have noted that this mid-segment looks like it's about half of BC. And indeed, it is indeed half of BC, so you can show that here. So notice that by setting this up, we actually get a very important theorem, probably one of the most important theorems out there involving triangles and their midpoints here. Now, I realize you could have done this using similar triangles with side angle side and all the other good stuff here. But note that we don't have we don't have that yet, but you can still do it that way. In essence, what I've just proved is this here. So this is an important theorem that I want everyone to focus on here, right? We can see that a line segment joining the midpoints of 2 sides of a triangle, this mid segment here, whatever this is, has 2 properties. One, it's parallel to the third side. Okay, that's important. And the second thing here is that it's half as long as the third side. So both of these are going to be very important here. They're going to lead us to be something that's going to lead us to important things further down the road. And note that the proof of this was not difficult. We were able to derive it by just simply going to our picture, our initial picture here, and just sort of messing around with it. And we had, and the power of congruent triangles and the like really served us well here. So that's going to be very important for us as we move along.